Good day. So in this video, I'm going to show you how to solve inequalities using a number line. And this method is quite very easy. So after this lesson, I assure you that you will never fail again in inequalities. And every time when you come across an inequality question in an exam, you will celebrate. But before we get into that, I just want to take this moment to appreciate all those who subscribe to my channel. And if you haven't subscribed, please hit that thumbnail on the right bottom corner there. So to discuss these inequalities, I have some examples that I have taken from exam papers from 2018, 2019, and to 2022. So it will be easier to use those questions. So let's just jump into some examples and show you how to do this thing. Now, before we get into this example, you should know that the difference between inequalities and equations is that the equations has got a solution set that are defined. It's an exact answer like 3, 5, and it can be 9. But whereas for the inequalities, it has a set of values that it obeys. So like for here, you see greater than 9. So there can be a lot of values that the inequality obeys. So that is the difference between the inequality and an equation. Now, getting to the examples. So these are exam questions that I have taken from the question papers. So in the first question, we are asked to solve the inequality x minus 1 squared is greater than 9. So yeah, what you want to do, there are actually two methods that you can use there. So what you want to do first is to find the critical values. So these are values where you use the equation. So you just say x minus 1 bracket squared is equal to 9. That's how you find the critical values. So in this case, x minus 1 bracket squared will be equal to 9. Then you can choose to use a method whereby you can bring the 9 this side, but I'm not going to bring the 9 that side because this is a square this side, so it's easy to find the square root of that side. So I'll just say x minus 1 is equal to the square root of 9, and then x minus 1 is equal to plus minus 3. Then once we have that, we can split the equation, and then x minus 1 is equal to 3, or x minus 1 is equal to negative 3. Then you find that the x value will be equal to a 4, or x is equal to a negative 2. Right. Now that you have your two values of x, the next thing that you want to do, so these are the values of the equation, not the inequality. So the next thing that you want to do is to draw up a number line. So you just draw a straight line. Then remember, negative 2 is on this side because it's less than 4. So then you've got your 4 here, right? So there are 3 segments where you can get your answer. You can either get your answer here, or your answer can be here between negative 2 and 4, or your answer can be a value that is greater than 4. So yeah, let's look into how we can do that. Now, to do that, you just, for this first segment here, this is side. So you just look for a number that is less than negative 2. So a value that is less than negative 2, we can just take negative 3. So if we take negative 3, we put it back into this equation here. So negative 3 for x minus 1, we get a 4, and 4 squared is 16. Is it true that 16 is greater than 9? Yes, it is true. Then you just put a tick right there. So it is true. So usually how they work is that the next one will always be wrong. So if we take a number that is between negative 2 and 4, we can put a 0. If we put a 0, 0 minus 1, that is negative 1 squared, it's a 1. 1 is greater than 9. That is false. That is not true. Then you check here another value. Here you just check a value that is greater than 4. And in this case, you can use a 5. So 5 minus 1, it's a 4. 4 squared is 16, greater than 9. Yes, it's true. So where you have got your ticks, that is your solution set. So in this case, x, so the final answer will be x is less than, so you don't put equal to because the original inequality had a greater than, no equal to. So you just say x is less than negative 2, and you check another one, x is greater than 4. And that is how you solve that inequality. Now, let's look at the second example. In the second example, we're asked to solve x squared is less than or equal to 3x. So the first thing that you want to do here is to bring that 3x this side. So it's minus 3x, then less than or equal to a 0. Then you just solve that for the critical values. So remember, for the critical values, you just x minus 3 bracket is equal to, so you just put an equal sign. So you just solve that x is equal to 0 and also x is equal to a 3. Now that you have the critical values, so remember the next thing that you want to do is to draw up that number line. So you put your values on the number line in order of their ascending, in ascending order. So in this case, x is 0, so 0 will come here and a 3 will come there. Now, so to test here, we just look for a number. Remember, our answers will be in 3 segments, either here, or the answer can be between 0 and 3, or the answer can be greater than or equal to 3. So we look for a value that is less than or equal to 0. In this case, I will just take a value of minus 3. If we take minus 3, remember, we put it in the original equation. So if we take minus 3 there, we'll put it there, that will be a 9. Is 9 less than or equal to negative 9? Is 9 less than or equal to negative 9? That is false. It can't be true because 9 is greater than that. So it is false here. Then we check here between 0 and 3. We just take a value of 2. Then 2 squared, it's a 4. Is 4 less than or equal to 6? Yes, it's true. Then we put a tick. And obviously this is going to be wrong, but let's just check. And you put a 5. 5 squared, that is 25, is less than or equal to 15. Is 5 squared, that is 25, less than or equal to 15? That is false. So where you have got your tick, that's where your answer is. So in this case, that will be x should be greater than 0. But remember, it's greater than or equal to, because that was the original. Greater than or equal to 0, but less than or equal to 3. And that is how you solve that inequality. Now, moving on to the other examples. Now, in this section, we are also asked to solve the inequalities. X squared minus 90 is greater than x. So yeah, remember, the first thing that you want to do is bring that x this side. So that becomes minus x minus 90. Then you just already say it's equal to 0 because you want to look for the critical values. Then remember how to solve this quadratic equation. So you just put an x, then you close a bracket, x and equal to 0. Then the factors of 90 in this case, that is simply a 10 and a 9. So that will be now a minus 10 and plus a 9. Because you're looking for the factors, when you multiply them, they give you a minus 90. But when you add and subtract them, they give you a minus 1. So then x will be equal to 10 and x also will be equal to negative 9. Remember, the next thing, you just put your values on the number line. So here it's minus 9, the smallest value, and 10 on that other side. Remember, our answers on 3 segment, either here, or the answer can be greater than 10. So the answer can be in here, less than negative 9, or between negative 9 and 10. So then we start testing the value. So we take a value that is less than negative 9. So in this case, a value that is less than negative 9, it's a negative 10. So if we put negative 10 squared, that will be 100. 100 minus 10, it's a 10. Is greater than negative 10. That is 10 greater than negative 10? Yes, that's true. Then we look for the value in between here, negative 9 and 10. And the value that is there, we can check a 0. So 0 minus 90, that is 90. Is negative 90 greater than 0? That is false. Then you check a value here. You just take maybe a value like after 10. So you just take a 20. So you say 20 squared, that is 400. Minus 90, that is 310. Is 310 greater than 20? Yes. So wherever you've got ticks, remember, that is your solution. So the answer is here and also on that side. So x is less than, so not equal to, but less than, because the original sign didn't have that, less than 9, or x is also greater than 10. So that is how you solve that. Now, moving on to this example. So this one is quite easy. You just, again, solve for the critical values. Then you just factor out x. Then you're left with 4 minus x is equal to 0. Then x is equal to 0. And also here x is equal to 4. Then you just put your numbers on the number line. So on the number line, so that's a 0 and a 4. So we test our values. In this case, we just test a value of less than 0. We can take even less than or equal to 0. So we can take 0. Or we can take a negative 1. Let's take negative 1. So negative 1 times 4, that is negative 4. Negative 4 minus 1, it's a negative 5. It's a negative 5 greater than or equal to 0. Is negative 5 greater than? No, that's not true. It's not greater than. Then we come here in between 0 and 4. We take a value of 2. So if we put 2, that will be 8. 8 minus 4 is greater than 0. Yes, that is true. Then we just take a value of 5 here. is 5, then we put 20 minus 25, that will be a negative 5. Is negative 5 greater than 0? That is false. So then your answer lies between 0 and 4. So x will be greater than or equal to, because this has got an equal to 0, and also less than or equal to 4. And that is how you solve that inequality. Now let's look at the last part of the inequalities. Now, if they don't give you the quadratic inequalities that we're doing, they can give you what we call the logical inequalities. So in these ones, they just ask you, you have to use logic to solve them. Like here, it is given that t of x is equal to the square root of x, 3x minus 5 over x minus 3. Then we are asked, for what values of x will this square root of 3x minus 5 divided by x minus 3 be real? So we want to see, where is it real? So remember, every time you've got a square root, you cannot get a square root of a negative number. So any value that is under a square root should always be a positive number, should always be 0 or a positive number. So with that in mind, we can actually say 3x minus 5 should be greater than or equal to 0, because that number under the square root cannot be a negative, because we don't have square roots of negative numbers in grade 12. So now we can solve that, and we can say 3x is greater than or equal to 5, and we just divide by 3. We divide by 3, then x is greater than or equal to 5 over 3. And that is part of the solution. Now, we are not yet done. We again check the denominator. We have got the denominator. And remember, the denominator cannot be 0, because anytime when you divide by 0, it will be undefined. So therefore, x minus 3 is equal to 0. We want to solve and see what will be the value of x for it to be a 0 at the denominator. So in this case, x will be equal to 3. So x cannot be a 3 at the denominator. So x cannot be a 3, because if it's a 3, then we have got a 0. So that is how you solve this inequality. So x will be greater than or equal to 5 over 3, or x is not equal to, and x is not equal to 3 for this expression to be real. And that is how you solve your inequalities. Let me know what you think. Please, I wish you good luck in your exams and or exercise, whatever you'll be doing. And yeah, I'll see you in the next lesson. It's a bye for now.